mute your face.
Oh. All right, so let's go ahead and share the screen first. All right, can you guys see my screen?
Yeah.
All right, so today's session is all about doing a network simulation with GNS3. So it may not sound something for the network security, but GNS3 is one of the software where you can test all the security applications you make or the protections you want to build on top of the applications. So today's session is basically to know how we can load Cisco routers on GNS3, installing GNS3 with VirtualBox. And I have already shared the resources in the Discord that you need to download and install the softwares. So a lot of the things what I'm going to show today may not be very comprehensive because there are a lot of backgrounds to the networking protocols, routing protocols. I don't know if you guys have taken the network administration course, but this is a little bit advanced level of network administration course because in network administration course of UNT, they only use Cisco Packet Tracer. So Cisco Packet Tracer has limitations, which is, it is only within that application that you can communicate. But the GNS3 has a capability of communicating outside the application with the host. I mean, with Windows 10 machine where GNS3 is installed. And you will get real router flavor. If you're configuring a real router or maybe real firewall, you will see the interface, but physically you cannot touch it or something, but you can configure the stuff. So I know a lot of Cisco router stuff, so I'm going to show things on Cisco router. But before I start, I'll need to give little bit information on networking part. So I'll just go ahead with the presentation. So first of all, the basics involve the IP addressing. So if anybody doesn't know the IP addressing stuff, you can go to a reference on IP addressing, how things work. So the network layer, which is a layer 3 of OSI interconnection, which forms the basic routing path of packet from one source to destination to other destinations. So everything goes through an IP address, all of you know. So these are just information what we need to know while we will be doing the lab. So, so network IP, it may be 192.168.1.0. And then it's just an example of how things would be. So there's a network IP, network ID. There's a host IP that is given to a host or a user or maybe a printer or anything. There's a gateway. Everybody knows what a gateway is. Then there's a broadcast IP where if we ping that address, the broadcast message is sent to all the IPs in the same subnet. And there's a subnet mask that how many users are available in that particular network IP. So in our case, there are 254 usable hosts that we can assign the IPs to. So, and the CIDR value is classless inter-domain routing /24. So if you see network IP consists of 4 octets with 32 bits. So out of 32 bits, this CIDR below 24 indicates that we are capable of having 2 to the power 8 minus 2 usable hosts. So what happened to -2 is first IP is a network IP and the last IP is a broadcast IP, which are not assignable. But the IP from 1 to 254 can be assignable. So that means 192.168.1.1 through 1.254 are assignable. So we have 254 IPs that we could assign. So this is how the network IP addressing works. So there are a lot of math behind it, like if you want to do a quick IP addressing, but this session is not for that. So let's go ahead. This is just an example. Okay, so basic network devices. So most of the time in our cybersecurity organization or anywhere, we only hear about the application level attacks. So, but the underlying the layers, what we need to know is that every layer has flaws and vulnerabilities that we need to keep a check on. So today we are going to see the layer 3 device, not layer 2. So layer 3 devices are mainly routers, but even if you speak about firewall, they also work at layer 3 and layer 4. If you speak about application firewall, they work at layer 3, layer 4, as well as layer 7. So there are different kinds of firewalls. If you come across the industry, whatever the companies are like Palo Alto, Cisco, or maybe Juniper, whatever. But today we are going to see layer 3 router. So what a layer 3 router does is builds a routing table for destination. So we are connected to UNT network through the switches or hubs. So UNT network on the external side is connected to one of the service providers, namely Frontier or maybe Spectrum. And then at the back end, from there on, they might be connected to AT&T, then the Tier 1, Tier 2, Tier 3 ISP. So this layer 3 devices are everywhere. So just if you get outside the UNT network, it goes through a router to a different destination, different network. So basically, it's all routers that transfers your packet from one source to destination. So they have all the routing tables to route packets. It's a network layer representation. So if you see in the OSI layer, it's at the layer 3 that does path determination and logical addressing. Records host attached to routers, whatever the host addresses are, it will be there in the router. Permit or deny traffic. So it will permit or deny traffic based on IP addresses, not based on the protocols. So if they are to address protocol layer protection, then we'll have to use the ports like the TCP or UDP ports, whether to allow HTTP or HTTPS and all those stuff. That also can be done. Many types of quality of service. So in a situation where there are 3 types of data that we know currently are data, voice, and video. These are the 3 types of data points. So just asking you a question, just to make it interactive. What do you think, which data, I mean, either data, voice, and video is the highest priority? Any guesses? Like suppose you have 3 data, so 3 kinds of data. One is only the data, and one is voice and video. So which one would be the highest priority for you?
I'm gonna say just plain data.
Yeah, I would say data too.
Video.
Okay. Any other guesses?
Video, then voice, then data.
Okay. So in networking and in everything, the most critical traffic is voice, because if the voice gets delayed, the message gets misinterpreted. So the priority comes like this: it's voice, then video, then data, because data is considered to be an email or a text or maybe a chat. Chat can be delayed. It does not have a misinterpretation. But if audio is delayed, it has a misinterpretation. So why I'm saying this is that the priority of traffic can be set inside a router so that the highest priority traffic gets prioritized before sending. So if we prioritize voice to have certain number of traffic, and then video to have certain number of bandwidth and the data, then the router decides which packet to forward first and which packet to forward last. An email can be delayed, but it doesn't have an impact on business, but the audio delay have a huge impact. So that's the understanding as per networking industry. So then we have the addressing technique, that's IP. So layer 3 just works on IP. Then we have the layer 2 switch. So hardly we speak about the switches because I don't know if we work on LAN attacks. So mainly in the MAC addresses, like medium access control addresses, which we can spoof and just configure in our own device within a LAN. So MAC address spoofing or attacks are within the LAN boundary, that is layer 2 boundary. So we might someday look at it, but I'm just giving you an overview on that. And addressing technique is MAC. So we are not talking about layer 2 switches today, but we'll talk about layer 3 router. So let's talk about the routing protocol. So mainly we know there are 2 types of routing protocol. There is an interior gateway protocol and the exterior gateway protocol. Sorry for the typo. So interior gateway protocol is in the sense like if anything within the campus, within an organization, if they want to run a routing protocol without communicating with the external ISP or some kind of thing. So that's the reason why interior gateway protocol were invented. And there are 2 types of interior gateway protocol. One is distance vector and one is link state. And under that, there are 2 types of routing protocol. One is routing information protocol and enhanced IGRP, which is distance vector. Distance vector mainly specifies number of hops a packet will traverse before reaching a destination. That's why it's known as distance vector. And link state mainly forms a hierarchical tree where the link states are advertised and the hierarchy of topology is maintained to route packet from source to destination. So these are just the basics. I'm not going to go into details. Then we have the external gateway protocol, which is a border gateway protocol. It's a huge protocol technology where service providers use this to route packets from one service provider to another, to AT&T or whatever. So BGP is kind of thing where if you even go on Wikipedia, you can find a lot of BGP attacks happening. People can just announce rogue routes so that they get different kind of legitimate traffic from banks. Maybe if UNT announces a IP address of YouTube, then all the nearby people will be hitting youtube.com, but they will be routed to us because we are announcing YouTube traffic if there is no YouTube server nearby. So that kind of thing happens through border gateway protocol if we don't seek protection. So we are not going to see external gateway protocol today, but we are going to see EIGRP and OSPF, and then how EIGRP and OSPF can communicate with each other. So let's go to GNS3 and VirtualBox. So we cannot finish all of GNS3 today. So these are the system requirements. It's Windows 10, it's fine. RAM of 8 GB would be good, and storage of 30 GB is fine. And the software requirements are the GNS3 software. So this version is compatible. I mean, this tutorial is compatible to 2.1.21. And then we have to have a VirtualBox. VirtualBox version is okay with 6.1 or 5.5. I don't have any, means we should not have any problem with that. Then we have the GNS3 VM OVA, then Linux L2, L3 images, and IOURC license. So Linux L2, L3 images are actually the Linux images which are used by Cisco routers in the routers as an iOS. So these are Linux versions which we can load in the GNS3 software as an image. So one more thing I want to tell is that we are going to integrate VirtualBox with GNS3. The advantage of integrating VirtualBox with GNS3 is that we can load 20, 30 routers with a minimum of 2 GB or 4 GB RAM. So earlier it used to happen that if you load 4 or 5 routers, your processor or RAM gets occupied very high and you cannot load more than maybe 5 or 6 routers. But with the addition of VirtualBox and GNS3, you can, VirtualBox has a way to minimize the RAM usage so that you can load as many routers as you want. There is an impact on RAM, but it's not that significant as how it would be if you only use GNS3. So I have already shared this part in the Discord. So I guess you guys have the software. So first thing is that we need to install the GNS3 software and VirtualBox software. Download the GNS3 VM OVA from that link and import the VM on the VirtualBox. So you have, so I will assume that you have imported the GNS3 VM on VirtualBox and you have installed the GNS3 software on the Windows 10. So yeah, in between, if you have any questions, please ask, because I'm going a little fast, I feel. So if you have any questions, please ask me. So let's go ahead and assume that GNS3 software is installed and VirtualBox is installed. So now I'm going to go to the next slide, setting up environment part 1. So I'm going to show that. So this file, this presentation I've already shared in the Discord. So if you guys want to have a look at it, you can go ahead and see. But now I'm going to change the screen. Yes.
Sorry, Syed, may I have a question about the previous slide?
Yes.
So IOURC license, what's that?
So that's a license which will be generated from GNS3 VM. So I have that license and I've already shared it. So that's a kind of a license which we need to put inside the GNS3 software so that it validates the iOS of L2 and L3 images.
But so is it free or you have it because of some previous achievements?
It's free.
Oh, okay, right. You
It's
just need
free.
to.
Yeah, it's free. So if you install something like 2.2 means the GNS3 version 2.2.14, then you need a new IOURC file. So there is a Python script to generate the IOURC file if you have a different version of GNS3 software running. So that Python script is found free. So if anybody
Okay.
wants that, I can just share it. But for this setup, anybody
Yes.
can use this IOURC license.
And the 30 gigabytes of storage, what are they for? Are they for Cisco virtual machines, or they are just for GNS3 software?
They're just for GNS3 VM.
Ooh, oh, that's pretty tough.
Yeah, I mean, this is just pretty much like for everything to go smooth. But so if you check, like, I mean, I didn't say 30 GB is too much.
Yeah, I mean it's okay, but yeah, I was just wondering. Okay, yeah. Anyway, thanks.
I think it would be less. Maybe GNS3 occupies 10 GB of space, but GNS3 VM occupies 10 GB of space. But this is just to be on safer side so that your system does not slow down. So that's
Okay.
the only reason. So it's not that
Fair,
much. Okay.
fair
All
point.
right.
Thanks.
So let's switch the share. Okay, because okay, share screen. So can you guys see my screen? No. Oh, this is not.
Yeah. Yeah.
No, I'm not sharing. I'm sharing the screen where GNS3 software. Can you guys see the GNS3 setup wizard and all stuff?
Yeah.
Okay. So, this is the first page after installing GNS3. Before this step, you will have to install the VirtualBox and load the GNS3 VM. So let's go ahead. So you will have to choose the first option, that is run modern iOS IOU. Those are the IOU routers you'll have. So let's click next. And then you will see host binding. So you will have to select host binding from here. So how this depends is that if you go to the VirtualBox, so give me a moment. Okay. Can you guys see VirtualBox? Can you guys see the VirtualBox?
Yeah, your entire screenshot.
Okay, okay, fine. Yeah, it's okay. So let's go to the GNS3 VM settings, and then you see the network. So you see it's a VirtualBox host only Ethernet adapter. So we'll have to check the IP of this so that this particular IP is selected here so that the host binding works. So let's go and check it out from the command prompt. So if you can see this, this is 131.1. So we'll have to select this IP here in the host binding. So let's go ahead and select the 131.1 and then next. Okay. Yeah, so this should connect to the GNS3 VM in the Oracle VirtualBox and try to start the VM. Okay, it says there's some problem. Okay, let's. Okay, could not find a VM named GNS3. Okay, let's go ahead with the setup. This part is already there in my slide. So if you have the slides already, if you follow that, you'll find. So let's go to select VirtualBox. Okay, fine. And we are going to use GNS3 VM. Then we are going to select next. Okay. Now it will load the VirtualBox, yes. So we can see that it's trying to connect here. I'm trying to start up the VM. Let's ignore this errors, this error. some errors that we can ignore. Actually, it's not going to have any impact. Okay, so let's see. I think, okay. So this is the next step where we want to add an IOU device, that is an iOS router. So let's select add an IOU device. So one thing to note is that you see here, the server summary, the desktop and the GNS3 VM. So most of the time, sometimes you might have an issue with GNS3 VM being grayed out. That means GNS3 VM is not connected to GNS3 software. So if you have that, then your setup will not work. So you make sure that this is green, and this is how you follow the setup. So let's go ahead and add an IOU. So run the IO device on the GNS3 VM. Okay, let's name it just Cisco router. It's a new image. Let's browse the image. So in my zip folder, you will see the zip file. You'll see a folder with IOU images. Let's go to image. So these are the images of Cisco routers and the version of it. So I'm going to select L3 Advanced Enterprise K9 15.2.2. Okay, and then I'm going to finish. You can see the router details. Okay, then apply. Okay. All right. So now we have So now we have a router in our system. So let's go ahead and open a new project. New blank project. Okay. Let's see. Okay. All right. So this is the router symbol where you can go ahead and check your Cisco router, which we have added. So this is the Cisco router which we have added. Let's go ahead and just take 5 routers. So if you see my slide, okay, okay, wait a minute. I think I need to share screen, get this. Okay. So if you see my slide here, so this is the routing topology, what we are going to build with today's session. And you guys have this file already. If you guys need to open this file while I'm trying to do things so that we don't slow down on our stuff. Let me explain to you what's happening in the topology first. So we have taken 5 routers, and the 5 routers at different places. So it's mainly San Jose, New York, Houston, Dallas, and Seattle. So Seattle, Dallas have the 2 customers actually connected to the 2 ISP. One is in San Jose and one is in Houston, and they're routed via New York. So what is happening here is that the particular IP addresses are assigned here. So address of Seattle is 1.1.1.1/32. Address of San Jose is 3.3.3.3/32. And then this is another address, and so on. So we are going to configure the network IP and the addresses on all the segments. Like this is one segment between San Jose and Seattle, between New York and San Jose, between New York and Houston, and then between Houston to Dallas. So I have also given the IP addresses of individual interfaces, what we're going to use. So this segment is going to use the IP subnet of 1.0/24, this one. This segment is going to use 2.0/24. So in this segment, we have 254 IP addresses. This segment, again, 254 IP addresses. So this is just an example. So a lot of IP is getting wasted here. So normally in industry, they don't do like that. They just take 2 IP. So let's not go there, like it's a different discussion. So here the IP segment is 172.16.10.0, and this is 172.16.20.0. And so this network is completely internal IGP routing protocol with EIGRP with autonomous system 100. And this is a OSPF domain or routing network where the process ID is 1. So this is the setup we're going to do, and I'm going to show you the whole thing. So I'm going to remove this slide because I'm going to show you how we are loading the routers and doing stuff. I hope you guys have the slide and you can refer it like that. And in between, if you guys have any question, please let me know. Okay, so let's go ahead and take the routers. Okay, so, and then we have 4 and 5. Okay, so let's name this New York.
Sorry, Sayed, may I ask a question in the meanwhile?
Yes, yes, sure.
First question is, why in the images that you uploaded, there is a name Linux? So that Linux L1, L3, so it should be Cisco iOS, right? Why, what's the connection to Linux?
So that version of iOS is, yeah. So that version of iOS is made to work in the GNS3 software. So if you look back, the Cisco iOS images are compressed version of Linux images, which is only prepared for routing purpose and having the routing tables and doing all the packet forwarding stuff. So Cisco originally used to name this as Cisco iOS Advanced Enterprise K9 15.2.2. But for GNS3 VM, there are special images which are named like this as i86. Linux Advanced Enterprise K9 15.2.2 something. So those images are special only for GNS3 VM. And those images are freely available.
I see. Okay, I got it. But the functionality is the same, right?
Yes, it's the same. It's the same.
Okay. Okay. And then another question, a little bit more technical.
Yes.
Why do you have to have GNS3 software running and you want to have its image in VirtualBox? What is the, I mean, why is it needed?
I didn't get the question, Dr. Marza.
Actually, I want to ask that too. Can't you just install GNS3 instead of putting it inside a VirtualBox?
Okay, so the reason behind having the reason behind having a GNS3 VirtualBox and GNS3 software is that if we want to load 20 to 30 routers inside GNS3, it's going to consume a lot of RAM and processing of the computer. So that's why they have come up with the concept of IOU routers, where we can have a virtual box to have the engine integrated with GNS3 and then load the IOU images. Without the virtual box, your IOU images will not be, cannot be run. So if we go to edit preferences, so if you see this IOU devices, so if you see this setting, run the IOU device on GNS3 VM. So we are actually loading the IOU images, but actually it is running on the GNS3 VM.
Oh, okay. Another version, so another variant is run the IOU devices on the remote computers. What would that mean?
So that's like some other version. So that's just there. I'm not sure why it is like that, but this type of IOU devices are on GNS3 VM. So there are other iOS routers which run directly on the local host. So if you go here, iOS routers, if you can add, run the iOS router on my local computer. So if you run it on local computer, it's going to consume more processing and RAM. So that's the reason why GNS3 has come up with this solution that run as much routers as possible with GNS3 VM so that your machine does not get slowed up.
Okay, I see. Thanks. Clear.
All right. So we were. Okay, so let's connect the devices. So let's go ahead and connect. So we have E00 connected to here, E00, and let's see the ports. Okay, then we have E01 connected San Jose to Seattle, E01. Then we have E01 of New York connected to Houston, E00. Then we have E01 of Houston connected to Dallas, E00. Okay. So I think I'm going to do a similar kind of. Do you all have the topology in front of you, or do I need to draw it? Just to ask. Should I draw the topology here? I mean, writing all the IP addresses and everything stuff, or do you have the topology with you on a screen?
This is just a bus topology, right?
No, that's a routing lab topology from the slide. From the slide I shared in Discord. In the meeting slide in Discord. Okay, let's go ahead. Sorry?
No.
Okay, let's go ahead and write the IP addresses so that if you have any questions, I think we can just do it. So, okay, I can't see the. Oh. Okay. So let's write the IP addresses here. So this network is 192.168.1.0/24. Then we have the Seattle IP to be 1.1.1.1/32. So, and then we have the San Jose IP to be 3.3.3.3/32. Okay, if you guys having a question and while I'm doing all this, you can just ask. The New York IP is 5.5.5.5/32. And then we have the Houston IP here, which is 4.4.4.4/32. And we have here Dallas IP to be 2.2.2.2/32. So I'm going to write the IP addresses of each interfaces here, which is 192.168.1.2 here of E01. Then we have 192.168.1.1 here, that's E01. Then we have 192.168.2.1 here of E00 of San Jose. Then we have here 192.168.2.2 of E00 here. Then we have 172 series, 172.16.10.1.
Sorry, can you zoom in a bit?
Okay, I'm sorry about that. Okay, can you see now?
Yep, thanks.
Okay, so this network, this is 24. Then this one here, this network is /24. Okay, this one here is 172.16.10.0/24. And this one here, 172.16.20.0/24. Okay, so, and now we have IP of Houston E00 172.16.10.2. Okay. And then we have E01 of Houston to be 172.16.20.1. And E00 of Dallas is 172.16.20.2. Okay. Okay, let's draw I'm going to have this go on there. Okay. And I'm going to type here, it's PIGRP 100. Then I'm going to do here another one. I'm going to write this as on there. Okay, I'm going to write this as OSPF1. All right. So let's go ahead and so this is what we have. Any questions here already, or are we fine? Okay, let's go ahead and start the routers here. So we're going to do the play button, or you can just start the router from here directly if you want to have a single router. So I'm going to just go ahead and write them. Okay. Okay, so license section not found IOURC file. So that's the reason we need a IOURC. So let's go ahead and see in the preferences to get the IOURC file. So where is it? IOU devices. Okay, browse. Let's go to the software IOURC file. Okay, apply. Okay, okay. So one thing to note is that we have to follow several step procedure to define a network, design a network, configure a network. So one mistake is done here is that I have removed the IOU numbers. Now the routers will be loaded with the IOU names. So I don't know which router is IOU 1 or 2. So I'm going to start one router at a time and change the host name first and then go ahead with the configuration. So let's start the Seattle router and start it. And then I'm going to console into it. So Seattle router was, I think, okay, so I think I have the name here, so it should not be a problem. So I think it is free. Okay, so it's a good thing I didn't know this until now. That the router name is just changed as I changed this name. So I think I can go ahead and start all of them. So I just started all of them, and then now I'm going to console to all of them. So
sorry, I just want to note that it's really amazing because I wanted to ask you, so when are you actually going to upload the real project? Because how do you assign all those IP addresses and so on? Because you have only picture. So are you telling me it's just that automatically assigning IP addresses according to the picture that you drew?
No. I'm going to configure them now.
Ah, okay. So you will actually do it manually. So that was just picture. It wasn't interpreted automatically,
yeah,
right?
That's just
wishful thinking. Okay, I got it.
Yeah, just because I share the topology, but I don't think people are having that in that their own laptop.
Right.
I'm going to just configure them now. Okay.
I see.
So
I see. Okay. Okay.
let's go ahead and do the configuration. So I just want to tell you one thing first is that in my presentation, I guess basic router configuration. So let me just tell you, can you guys see my slides? Okay, cool. So whenever a router gets started, it has a different prompt. One is enable prompt and one is configure terminal prompt. So if we want to configure anything, we have to go to a configure terminal prompt and then start configuring stuff. This is particularly for Cisco routers. So, and Cisco iOS routers. Cisco has got currently 3 kinds of iOS. One is iOS router, one is iOS XE, and one is iOS XR. The reason why I know is that I have worked with all of them, but this is the basic level first with a minimum resource consuming router, which we can learn. So configure terminal, the first command, and then we can change the host name with the hostname command. Interface IP addresses to set, I'll show you how it is. Then we have to configure the management interfaces. So most of us, like whenever you're going to design a network, we have to consider defining a management network because the normal traffic network is never used for management purposes because it will disrupt the traffic of other communications in a business critical design. So management interfaces are separate than the normal data traffic. Then we have to configure the routing, which is OSPF or EIGRP. Then you can see on the right-hand side that we are defining the hostname, the interface, and the IP addresses. So I'm going to go ahead and do that now. And you guys can ask questions whenever if you have any. So let's just, for instance, I'm going to change the host name and just see the changes, but we're going to keep the host name same as Seattle.
Two questions.
Yes.
Separating management from the client traffic.
Yes.
Does management really take that much of the bandwidth? I mean, unless you're trying to listen on the wiretap on the client's traffic, so why would that take some bandwidth?
Yeah, that's one of the reasons that we are going to be inside the device. So the management network, that is always considered to be out of band management, because the data traffic should not be allowing the management traffic. So the data traffic does not have any SSH port allowed for anybody to log into that port. So because of that reason, people in the network industry keep the management traffic separate than the normal data traffic. So management traffic will allow SSH or telnet to the device, but the data traffic will not allow SSH or HTTP or any other management traffic to the device. So that's another reason. So there are many reasons that why the management traffic should be separate than the normal traffic.
Okay, fair point. Another question, do they still use telnet for routers? Because yeah, telnet doesn't encrypt connection, right? So it's only if you have a protected line, right?
Yes. So telnet is still there, but people don't prefer using it. So, but you will need to generate the SSH keys inside the router for SSH terminals, so which I'm going to show in the router, but normally telnet is not preferred, so we'll not be using telnet in our lab as well.
Right, good, thanks.
Okay, so let's go ahead and configure the interfaces. So let's say interface E0x1, IP address. So that's the IP address and subnet mask. Then we can just add a description here saying that it's connected to San Jose. I can say E0x1 or something. Then we'll have to open the interface saying that no shutdown. So this will open the interface and keep it in the connected mode. So you can see that link. Can you guys see it? Like, is it very small or it's fine?
Can you do a Control+ on it?
Control plus. Okay, this is not the same. So I think I need to change settings. Okay, apply. Is that fine?
Yep.
Okay, so let's go ahead and see. So I'm defining an interface loopback address. So it's similar to loopback of Microsoft 127.0.0.1. So I'm going to define the loopback as IP address 1.1.1.255.255.255. It's just single host. So I'm going to write the configuration here. So that's saving the configuration. So if you want to see the interfaces that are configured, you can just write it as show IP interface brief. So it's going to show E01 and then the IP here. So I can just filter this based on how we use in Linux, any command, grep, whatever is like excluding or inclusive part. So if I show IP interface brief, exclude unassigned. So you can see only the IP addresses that are only configured. So there is one more protocol, there's one protocol in Cisco where you can just check what routers are connected or which devices are connected to the Cisco routers. So that is the command show CDP neighbors. So now the other side of the interface, like San Jose, is not being configured, or the interface is shut. So we cannot see the interface. We cannot see the device. So let's go to San Jose and configure it. Then we'll be able to see what's happening. Okay, so let's go here, interface E0 by 1, IP address. Okay, it's going to show up in some time. Okay, so you can see that this device, Seattle, is connected to San Jose on a local interface E01, and the remote interface is E01. So that's how the Cisco discovery protocol works. If you do show CDP neighbors, it will show you the neighbors in the same LAN. So I'll go ahead and configure all the interfaces now. Just have some patience on with me. Interface E0 by 0, IP address 192.168.2.1. All right, so, and then we have New York router. Okay, let's go to Houston router. E01. So I have IP addresses. Then let's configure this Dallas, the last one. Okay. So you can see that I'm not putting any no shut command in the loopback, because loopback interfaces normally does not exist as a physical interface, but then to the Cisco routers are just enabling the no shut command on the loopback interfaces. So it's just up and running as soon as I declare it. Interface E0 by 0, interface. So we have all the interfaces configured at the moment. So now our job is to configure routing. So first of all, let's check, is there anything in the routing table of the router? So the command is show IP route. So you can see the locally available routes, locally connected routes are only available. That is this route and 20.0, which is connected to the network. So let's go ahead and configure the routing protocol. So let's see what we need to configure in the routing. Okay, it's not there. Okay, so I'll go and configure this. I think you can refer to me later. Okay, so I'm in the Houston. So let's start from Dallas. So I'm going to do OSPF configuration here in the Dallas router. So let's go to the configuration. So router OSPF 1. So I need to add this command to the slide, and I'll be sharing the slide again. So this will be end of the session. So just be with me for this. So I'm going to put the network command, which is so we have two network, and then so I'm going to speak a little bit on this. So configuring OSPF or open shortest path first involves area declaration as well as route declaration. So we have to declare the network which are connected to the router in the router OSPF segment. So here you can see the network command having the network IP and the subnet mask or wildcard bits. So this is the wildcard bits, which is opposite of the subnet mask. So this is the format which is used to advertise the network in OSPF under area 0. So in OSPF, we have multiple areas like area 0, area 1, area 2, but area 0 is supposed to be the backbone area where all the other areas go through area 0 and then go to other areas to route the packets. So any questions here? I guess no.
Nope, you're doing great. Thank you.
All right. Okay, so then we have to put the network of 172.16.20.0. So these are the two networks which we have inside this router. So I have just enabled them, 20.2 and 2.2.2.2. So inside the Dallas routers. Let's go to Houston and configure the router OSPF there. So we have network 4.4.4.4 under area 0. And then we have network 16.20.0 255 area 0, which is a wildcard bits. And we also have another network, which is network 172.16.10.0 0.0.0.255 area 0. Okay. So I guess the show IP interface, show IP OSPF neighbors. Okay, so I have a communication with the Dallas router, but I don't see it has formed the neighborship. So once we configure the router OSPF, I should see a neighborship up and running. Okay, yes. So once I run the OSPF router command, it should show me up the neighborship status. It is now formed neighborship with the Houston routers form neighborship with Dallas, and Dallas router form neighborship with Houston. So now the Houston router will have the route of 2.2.2.2 in its routing table. Show IP route. So you can see there is 2.2.2.2, and it can also ping the route. So, I mean, I can repeat it 10 times or 100 times or whatever. So similarly, I'm going to go and configure the New York router. Router OSPF1, network 172.16.10.1, 10.0, 0. And I'm not going to include 5.5, just I'm going to include it somewhere else. So New York router will also have access to the routes from Dallas router. So let's see it has formed the neighborship or no. I think the interface is not opened up here. Yeah. So if you see the interface is shut, so I have to unshut, like put a no shut command in that. No shut. Okay. So it has formed the neighborship. So IP OSPF neighbor command will give us the neighborship. Now I can see the show IP route routing table in the New York router. So you can see that 2.2.2 is here. So I can ping the device router from, ping the network from here. I'm sorry. Okay. So this side was supposed to be OSPF, which is already configured. Now let us go and configure the EIGRP on this side of the New York part. So let's go to New York device and configure the EIGRP. So let's say router EIGRP 100. So this 100 is a identification of autonomous system. So autonomous system, we can say autonomous system is a domain of route. So if you want all the routes to be a single domain, like autonomous system 100, all the routes can be in the same domain. So the significance of the autonomous system is that if you go to BGP, like the border gateway protocol, they also use autonomous system to identify a particular set of networks. So suppose UNT has a autonomous system number of 58,776 or something. So all the service providers have an autonomous system number to communicate with their external service providers. So that's the importance of autonomous system. So let's say router EIGRP 100. Then we're going to define the network. Okay, so one thing is that we have to define no auto summary here, because EIGRP routing protocol summarizes networks in a classful networks. So I guess if you guys have taken network administration, there is class A, class B, class C networks, which have particular CIDR value. So just for the time being, I think just consider understanding how this works. We can talk about it later if anybody has any question. So I'll go ahead and configure it and later talk about it more. 5. Okay. Okay, let's go to San Jose router. So the EIGRP autonomous system has to be same in all the routers to form the neighborship in the same autonomous system. But OSPF process ID, where we write router OSPF1, do not need to have any kind of autonomous system, because the process ID is individual to that system. It is not advertised. But autonomous system is advertised to the next router so that they form adjacency based on the autonomous system number. So let's define no auto summary network. Okay, let's go here.
Said, may I have a question?
Yes.
So it's about Cisco iOS system.
Okay.
So you use WR command, right? It's a writing current configuration.
Yes.
Would copy run start do the same thing?
Copy
run start.
Yes. This also copy running config, startup config also will do the same thing. Yes.
Right. Is it the same or
it is the same thing. So it is writing to the NVRAM. So
okay.
Whenever we say running config, startup config, running config is not been saved. So that's why we are copying the running config to a startup config in the NVRAM. So whenever router reloads, we'll take up the startup config and load the whole stuff, all the configuration details. So now if we don't save it using copy run start or write command, then we lose the configurations.
Okay, so it will exist only until the restart, right? So every
Yes.
time you do the write in order to fix the current configuration. Okay,
Yes.
thanks.
Yes.
Thanks.
Okay, so now I think we have all the. So any questions from the others? I don't see any questions. I guess, are you guys understanding or like I'm just speaking?
You're doing really good, man.
Karen, you there?
I'm following along.
All right, so I mean, it might be a little advanced, but I think we can always discuss in Discord, so not a big issue. I mean,
Yeah,
this
yeah.
will be helpful for you guys, you know, if you want to show some network skill set or maybe some kind of configuration that you need to know, you can always go for it because mostly 70% or 80% of the market, I don't know, in US maybe, use Cisco routers because they're the most reliable routers in the industry. Anyway, so now what we are seeing is that we can reach from Seattle to New York through EIGRP, and we can reach Dallas to New York through OSPF, but we cannot reach from Seattle to Dallas. So for this, we need to have a conversion at New York router because both the routing protocols are configured at New York. So we need to redistribute. There's a process to redistribute OSPF routes inside EIGRP and EIGRP routes inside OSPF. So we are going to do that now so that we can see all the routes in here. So let's go ahead and go to New York router and redistribute the stuff. So router EIGRP 100. We have to have a default metric. Default metric is something that when a route is redistributed, okay. So when okay, Kristen was saying something, I missed it. Okay, I'll just continue and take up the questions later. So default metric is something is that every routing protocol has its own way of assessing the best route. So if you think of OSPF, they take a link state to define the best route. But if you take EIGRP, they have a different topological view to take the best route. So what the default metric will do, whenever we redistribute from a different routing protocol to a EIGRP, EIGRP will define these default metrics to reach that route inside another external routing protocol. So that's why the default metric, whenever you define the redistribution of another routing inside the EIGRP, will take the default metric which is defined here. So default metric, I'm going to define it here, bandwidth maybe 1000. So this is just custom, the way you want it to be. And then delay metric can be 10. Reliability is 255. And then we have this also, no, this has 1 because it's not loaded. And then we have maximum transmission unit to be 1500. Okay, I can't explain all of them now, but yeah, this is just default. So let's redistribute. So we are in EIGRP, we are redistributing OSPF into EIGRP. Let's go ahead and do a redistribution inside OSPF. Redistribute EIGRP 100 and then use subnets. So that's the main process of redistributing between two different routing protocols inside Cisco IOS routers. So let's go ahead and see if we have any routes coming in here. So IP route. So if you see here, the external routes now, 2.2.2 route of Dallas, 5.5.5 route of, 4.4.4 from Houston, and the other two networks, 10 and 20, which are this and this is available here. So now if you want to, so one of the things what we have to remember is that if we redistribute only one side and leave the other side, the routes will not pass. I mean, the packet will not traverse. So you need to make sure both the domains have the routes to reach each other. I mean, it's a kind of a full duplex kind of a road or something like that. So if you go to Dallas here, so you should be able to get the routes. You see the OSPF routes is designated as O. If you see here, OSPF, and EIGRP routes are designated as D. And then there are two types of external route for OSPF, which are E2 and E1. So this is type E2. So we have these external routes from EIGRP. So now we have 1.1.1 in Dallas. So now we should be able to ping 1.1.1.1. So yes, so we have a reachability. I mean, we can just go anyway. So let's go ahead to the next section. I'm trying to wrap this up in 20 minutes now. Though. We have some security protections that we want to show. So let's see what we have. So three kinds of protections, what we can talk about in security. One is management plane protection. One is control plane protection. And one is data plane protection. So what is management plane protection is who gets or what kind of access is given to the device. And there is a control plane protection, what kind of traffic or the routes can be shared among each other. And then, okay, and then we have data plane protection, which is controlling what kind of traffic is allowed. So sometimes you want to allow a TCP traffic, or sometimes you want to allow only HTTP traffic through something. So I'm going to show a little bit flavor of each of them. So let's see. Okay, so this is the SSH access, what we are going to do in one of the routers and check how things work out. So let's see in the Dallas router. So if you check now from Seattle to Dallas, it will not, the SSH will not work because it's not configured. So SSH -L, so it's a login. So SSH, then if you just do question mark, you can see what are the options available. And login using this username. So we don't have any username configured in Dallas. So let's go ahead and configure a username here. So username Cisco, privilege 15, secret Cisco. Okay. So this privilege 15 means that this username, okay, this username is going to have full privilege if it is logged in with this access credential. So there are different privilege levels between 1 to 15. So I'm going to define this user with full privilege. Okay. And then we have AAA new model. Okay. This is for authentication authorization part. And then AAA authentication, login default local. This is another command. I'm going to say about it later. So we're going to manage, we're going to configure the management access of this device with this command, line VTY 04. That means we have 5 terminal point access. And then we're going to say login local. Sorry. Okay. Authentication default, okay. And then we're going to have transport input SSH. Yeah, this is what we have here. Okay, we have to do enable. This is enable secret. Okay, so I guess this should work. Okay. So let's see if it is working. I had a different configuration yesterday. -L Cisco. Okay. So I think we have an issue. Push. Sorry. Should be default. I don't know. Okay, I think there's some issue with that. I checked it yesterday, but I didn't give any issue. So I'm thinking that.
Okay, Said.
Yes, sir.
Could you please repeat what we are doing now, just in case?
Yeah, I'm trying to set up the SSH access of the device router. So I'm getting some issue here. So I'm just trying to.
Okay. Yeah. Oh, I see. You are on router, and then you want to allow yourself to connect to it via SSH, right?
Yes.
From
yes.
outside, remotely.
Yes.
Okay.
Yes.
Okay. Okay.
Okay, I think I have to check this out and come back later. So I'm going to stop this here. Let's go ahead and see control plane security. So we have options to define access list and control what routes are actually can be advertised. So this is one of the examples where we can show what routes can be advertised to different routers. So suppose in the environment where we want to see that we don't want Seattle to have access to 2.2.2.2, or maybe this part should not have any access to 2.2.2.2. So we can do the configurations at the New York router and check this out. And then we have data plane security, where we can define the IP access list to deny any access from anyone to this 4.4.4.4 or whatever. So let's go ahead and see data plane security for once, and then I'll come back to control plane security. So let's go to this device, which is 4.4.4.4. I guess it is Houston. Yeah. So I'm going to define it IP access list extended 100 deny ICMP any to 4.4.4.4 with host mask wildcard bits. We can say it's echo as well as echo reply. Okay, so let's check if it is available now. Ping 4.4.4.4. Okay, it's already available. Okay, so I have denied the ICMP. So by default, what happens is if I have a deny statement, I have to have a permit statement at the end, because otherwise all the traffics will be denied. So I have to say permit IP any. So I have the access list now. Now I have to apply it into an interface. So I'm going to apply the access list on E00. So let's go to interface E0 by 0. IP access group 100 in. So I have configured the IP access list. Okay, so this is what access list looks like. So it is going to deny any ICMP echo and reply stuff. So let's go ahead and see ping 4.4.4.4. So it's giving unreachable. So if you search on Google, what does U mean and what does that exclamation mean? Exclamation is that host is reachable, and U means the host is unreachable. So my point is that this is functioning well. So if you want to deny any traffic coming into a host, or maybe a particular traffic in the data plane security, we can do that. So let's go ahead and see how can we define control plane security, controlling what routes should be available. So that's the last part of my presentation today. So I'm not going to do much stuff. So now if we can see here, show IP route, I can see that I have this 2.2 route. So what I'm going to do is that I'm going to filter routes here so that I'm going to avail only this route and rest of them are filtered, like 4.4 or whatever, this something. So let's go ahead and see how can I do that. Is that okay? So we have to create. Okay, first we have to create an access list and the New York router. Access list 1 permit IP 2.2.2.2 0.0.0.0. Okay, this is what. Okay, we don't have this statement. Okay, permit. Then we have to create a route map. So route map is a big terminology in Cisco routers. If you go and see a lot of things we can do in the route map. So we have to create a route map and add the access list to the specific route map. So let's say we had a route map, create map, route map, and then we have the name of the route map, suppose external, ext, and then we have to have a permit statement with a sequence number 10, and then we have match IP address 1. So this one refers to the access list given here. Okay, so we have to deny all other routes, because if there's a permit statement, then everything is permitted. So we have to have a deny statement, because permit statement can also permit other stuff. So we have route map ext deny 15. Okay, so let's go to EIGRP, where we have redistributed OSPF routes. Now we'll redistribute OSPF routes with this route map, whatever is configured here. So let's say redistribute, router OSPF 1, no redistribute OSPF 1. Okay, I'm sorry, we should go to router EIGRP 100. No redistribute OSPF 1, distribute OSPF 1, subnets, route map ext. Okay, so now we should have only 2.2.2 here, so IP route. So you can see that we only have access to this route here. So so rest of the routes are gone. So we can ping 2.2.2.2, but we cannot ping others. So yeah, so that's, I think, the end of my presentation. I guess I don't have anything more to say today. So this is just a basic of how you can actually configure Cisco routers inside the GNS3. So if you just have a look at the devices available here, there are a lot of devices like ASA firewall, then there is NG IPS, and these are just Cisco, but there are a lot of other checkpoint, FortiGate, other lot of stuff. So one of the things what you can do is you can load a Ubuntu VM here and here, and then try different applications and run through this whole thing, set up the DNS server, and check out the whole network operation from the GNS3 software itself. So this is one of the good resources. I guess you guys have understood something what is to be done over here. Yeah. So yeah, that's all for today. Any questions?
A short question.
Yes.
So suppose we say, give us more. So tell us more. What would you tell us? What would you add to this? So yeah, I realized that, yeah, so maybe explaining SSH setup, yeah, again, yeah, but apart from that, so apart from the current curriculum, what else would you tell us about network security using routers? Not switches, just routers.
So just routers, I guess we have more to do with the specific ports and the routes and the access management. Apart from that, there are some kind of DDoS attacks that can be created. So there are some kind of TCP attacks. So what happens is that whenever we want to have a connection between a router and another router, maybe host, there is TCP communication of SYN, ACK, SYN, and all those stuff. The DDoS attacks happen in that way that it sends TCP SYN flood. So it keeps sending TCP SYN flood until the router is unable to respond to the acknowledgement. So the SYN open ports are being opened at the router end, and it is sending acknowledgement, but the acknowledgement is not being received or maybe acknowledged by the other router. So that router is the rogue router who is trying to have a TCP SYN flood and flood the router. So that's one of the things that we can configure in the router.
Okay, so it's a protection against SYN flood attacks, right?
Yes, yes. So another thing that we can talk about is the fragmentation of the IP packet, or maybe setting a no fragmentation on the IP packet. So fragmentation have a major thing. If the fragmentation goes wrong, like normally there is a maximum transmission unit of 1500. So sometimes the packet go above 1500, like 1700 or 1800 at the network layer. So if we don't set the defragment bit, then the packet may not be transferred and there might be communication problem inside the router. So sometimes what happens is that if an attacker gets access to that router and then set the DF bit off, and then if any packet is going above 1500 MTU, then the receiver will not receive that thing properly. So that's another thing you can see. And then I think the rest of them.
Maybe quality of service, so setting the throughput.
Yes, so quality of service are like differentiated service code points. So that is kind of not, I mean, how will you relate to the security? I'm just thinking.
It's not exactly security, but it's, I mean, it's nice to know, you know, kind of some things that are
so there are quality of services of different coloring of traffic. So actually the coloring of traffic are done between voice, video, and data traffic. So there is assured forwarding, then expedited forwarding. So those things can be done per interface basis. So we can do that. And mostly the filtering of traffic is done at the interface level. Like if you want to filter any unknown traffic, which is not supposed to pass through the router. So those kind of port level filtering can be done on the routers. And apart from that, there are intelligence in the router to recognize the applications. What kind of applications are running through the router? So it can be Skype, or it can be Torrent, or it can be any other applications which is there in the Cisco database. So they can see the behavior of the traffic and analyze, like it is called NBAR, network-based application recognition. Cisco calls it NBAR. So in that, you can Cisco can identify what kind of application is currently running inside the router. So I don't know if I can show that.
Oh, I'm not. Yeah, I mean, yeah. If you didn't prepare it, it's fine. But that sounds interesting as well, I think. Yeah. So application level proxies. So like packet inspection. That's really interesting. Yeah. I mean, built-in protections that are built in Cisco IOS. That's very interesting too. Okay. But anyway, yeah. Thanks for excellent presentation. That's really nice. Yeah. Thanks.
Yeah, so I guess I need feedback from at least Michael and Andrew and Perrin. Like, how is this relevant to the stuff that we are trying to do in cybersecurity?
I mean, I enjoyed the presentation. I learned a lot. I know there's a lot of things that I don't know that you showed here, and I'm definitely going to rewatch the YouTube video to pick it up again. But I think from what I could pick up, I learned a lot, and it was good.
Okay.
Same here. I actually haven't done a lot of networking, so this was actually just very informational for me, like all the way around, honestly.
Okay.
Kind of gave me a taste of it.
Okay. Okay.
It was very easy to follow, though.
Yes. Yes. So, yes, Michael.
I mean, I jumped in near the end, so I didn't see all of it, but what I saw seemed really good. It seemed like you're going into an appropriate level of detail. So nice job.
Yeah. So yeah, that's the I think stuff that we're trying to do. So this can be detailed more maybe in future, maybe router level security or maybe application level security. Maybe we can talk a little bit about more firewalls that are available. But I need to also focus on the application kind of thing, like what kind of application that we are trying to protect and what kind of security, because the stuff we do in UNT cybersecurity is mostly at the application side, and we don't talk much about the network, I guess. So I'll try to put up some more stuff in future, maybe make students understand more.
That'd be really cool if we could talk about like packet capturing and everything. That'd be nice.
Yes, yes.
Yeah,
so, yeah.
That'd be really fun.
So that are some of the stuff which I'm going through NCL, and I saw that they're trying to ask me questions on the different what is the attributes inside the packet, like the DNS, what is the DNS query and all this stuff. I guess Karen have worked on it, maybe Michael. I got some of the questions there. So the Wireshark is one of the very important thing where we need to see the details. Maybe the next session in future, whenever we get time, we'll have a session on Wireshark and capture packets from here.
I'd like that a lot. That'd be really cool.
Okay. All right.
Wireshark,
Yes.
Wireshark would be great.
Yeah.
I'd like to, if you don't mind, do you mind if I make an announcement as well?
Okay. Announcement about like what?
It's actually an announcement for an application that's about to go out, if that's cool by you.
Oh, that's fine. Means about this application or
No, just a different school application.
okay. Let's talk about it again. I need to understand what you're saying, so no problem. I can do that, no problem.
Gotcha. It's not talking about the presentation today. It's talking about another subject entirely, if that's all right with you. If it's not, we can talk about the meeting a while longer.
Okay. All right, fine. So Dr. Morozov, anything else?
Not that I can think of. Thanks again for the presentation. It's really nice. And maybe I'll come up with something, then I'll tell you later, but it really looks good. I wish, I mean, so maybe actually, I'm sure that after some polishing, this could be a good lecture for the for some of the courses. I think one of the participants mentioned maybe network administration, but I wouldn't mind including it as a guest lecture in the introduction to computer security course. And if you don't mind, I will share a link with the students, you know, so that they can like it's a supplemental reading. So, you know, I'll give them the link if they are interested. They can have a look because I think it's instructive. It's really nice.
Okay. So yeah. So in security, so one more thing we could show, I just forgot, is that VPN, virtual private network. So
oh, yeah.
So if you want to do a IPsec VPN or maybe the
right.
SSL VPN, so
I
those.
was actually intending on doing a lecture on how to set up your own virtual network using AWS.
Okay. So
IPsec would be good as well. Yeah. Okay. So that's something that yes, covering IPsec would be nice.
So we could have so IPsec VPN is one thing that we could do, and I guess there are a lot of security stuff we can do. So I need to just come up with a plan if you feel so that we can discuss more on this. And just to add with Karen is that AWS, if you go to AWS networking, there are a lot of stuff that you can do. Just starting from the compute, loading a compute, and then managing the network of AWS is a big stuff. So I did AWS course earlier 2 years back, and it's free for 12 months. I mean, if you just pay $1 from your debit card, it's like you get access to the basic configuration of compute, network, storage, virtualization, all the stuff. So you can get a feel of that. So yeah, that could be a good thing on AWS. So I was seeing recently UTD has done a ethical hacking session. So maybe this kind of setup in GNS3, we can bring up the whole setup beforehand and then try some ethical hacking stuff from one host to another host through the network and maybe set up something like that. Yeah.
Yeah, that'd be cool.
A question: Do we still need a recording, or because it seems like we moved into an informal?
Oh, sorry. I can just stop the recording. Sorry.